Hello, geometry folks. Today we're going to be starting a second section in our unit 4 of congruence, and now we're going to be talking about congruent figures. So all you'll need today is your notes, and you don't need a foldable, a pen or pencil, and calculator. Our learning goals or standards today, and you don't need to write these down, are to use the definition of congruence to show that two triangles are congruent if and only if the corresponding pairs of sides and the corresponding pairs of angles are congruent. And now by using those definitions, we're going to use the congruent triangles definition to prove and solve problems and relationships in geometric figures. So this slide is going to be the first slide that you're going to write in your notebook for today, and that is the definition of congruent figures. When two figures are congruent, we're saying their corresponding angles are congruent and their corresponding sides are congruent, or the sides of the triangles that match in length or the angles that match in degree measure. And that's just what the next bullet says. The sides and angles that match up absolutely perfectly, that are the same size and same shape. So remember last unit we talked about transformations. If two figures were either rotated, translated, or reflected, those were congruent transformations, and that's where this comes into play here. This first example, you guys, I just want to have you think and listen through it with me rather than writing it down. So don't feel the need to write it down in your notes necessarily. But our given statement is the statement or the figure A, B, C, D, E is congruent to the figure F, G, H, I, J. And this is called a congruent statement. If you want to write that in your notes, or if you want to jot it down later, that's totally fine. But just for your future knowledge, when I say congruent statements, this is what I mean. And they're not just alphabetizing this order. There's a reason, there's a rhyme and a reason as to why they were listed in the way that they were. So I'll explain that in just a little bit. If we take the first part of, or the first two letters in our first figure, this is the segment AB, this segment right here. So that's showing that segment of the entire figure. We're saying not only is AB that segment of the figure, but it's congruent to the segment FG. So the order does matter when you're writing your congruent statements from an image. We're saying the segment AB is congruent to the segment FG. So we know that, so let's mark it with our congruent slash marks on the figure like we've learned in the past. So if that's the case, that's also the case for line segment BC and line segment GF. So we can hash mark those. BC is congruent to GF. And then CD is congruent to HI. So we can do 3 hash marks on CD and 3 hash marks on HI. And then we have DE is congruent to HI. So this is getting a little obnoxious, but I think you know where I'm going with it. 4 hash marks on the line segment ED and IJ. And last but not least, because we only have one side left on the figure, and we know that these figures are congruent because they told us, line segment AE is congruent, it's 5 hash marks there too, to the line segment FJ. So 5 hash marks there. But we just said in our definition that congruent figures not only have congruent segments, but they have congruent corresponding angles. So what that means is angle A is congruent to angle F. So because angle A was listed first and angle F was listed first, that notation is telling us that those two angles are congruent. So that means that the angle B is congruent to the angle G. So I'm making hash marks on my little image of those two. And then angle C is congruent to angle H. And I could keep going on with ID and EJ and all that. But down here it's saying what can we conclude, and that's each part of the image is congruent to the other image. So you could essentially, under this question, what can we conclude? We could write the line segment AB is congruent to the line segment FG, and we could generate that whole entire list of all the hash marks that I just made, but I'm not going to do that because this was just for an idea. Okay, so this is our first example that you want to put in your notes. If you want to take a second to pause the video to write this down, you can, but just make sure that you copy both images exactly as they're shown here. So our first question here is to determine if these two images are congruent. So essentially what we're doing with this is we're going to find each angle to see if they're congruent and find each side to see if they're congruent, corresponding sides and angles, that is. So right away, I'm going to start with a point, and it doesn't matter what point you want to start with, and I think it's easiest to find angles, corresponding angles first. So I'm going to start with point A, and point A measures 80 degrees, and there is another angle on the second image that also measures 80 degrees, and we actually have two in both images that measure 80 degrees. So you can put a tick mark there showing that all four of these angles are congruent. And we can do the same thing for the four angles that measure 100 degrees, which is points B, C, F, and G. So now that we found that all of the interior angles are congruent to a corresponding angle in the second image, let's check our sides. So if we just pick a side to start with, I'm going to pick the side AD. That measures a unit length, I guess, of 10 units. And there is another side on the other example, or the other image, that also measures 10 units. So those two match up, so they're congruent. And then we also have a side length of 15 on one image and another image on the second image, and then we have another side length of 15. So all four of those sides get the same amount of tick marks, which is 2, because they all measure the same length, which is 15 units. And then last but not least, line segment BC is congruent to line segment FG because they both measure 4 units. So now we have to make sure that the points in the order that we write them are corresponding. So our two shapes could have all of the same angle measures and have all the same angle lengths, but one image might not have had it in the same order as the other. And our two images here look like they do. So we're saying that point A corresponds to point E, and point D corresponds to point H, and point C corresponds to point G, and point B corresponds to point F. And if we were to write our congruent statement, then we could do it just in that order. So we would start at point A, we would go to D, we would go to C, and then go to B. So it would be ADCB is congruent to, now we have to write it in the same order. That's the whole point of a congruent statement. It's telling us which side lengths and which angles are congruent. So the order does matter. So we're starting at point E because that corresponds to point A. And we're going from E to H to G, F. So our second image would be E, H, G, F. Oh, G, F. And that would be our congruent statement. And the answer is yes, our two images are congruent. Okay, so I'm going to do 3 examples really quick, and you do not need to write them in your notes. It's just to get used to writing congruent statements, so just watch along while I explain these 3 examples. So our first question is to determine if these 2 triangles are congruent, and then if so, we're going to need to write the congruent statement. So we have triangle EIG and QMO. And I can tell by all the hash marks on both triangles that we have three congruent corresponding sides and 3 congruent corresponding angles. So so yes, my 2 triangles are congruent. That was the first question. Now I just need to write my congruent statement. So we're saying triangle, and I'll start at point E on this first triangle, E, and then I'll go in this direction, EIG. So triangle EIG is congruent to, now remember, we can't just write any order. We have to go in the same order as we did with the other triangle. So E and Q are corresponding points, so I'd have to start at point Q. So we're saying triangle EIG is congruent to triangle QOM. So let's take a look at another example. Here our image is a little more funky just because the triangles are touching and they're not facing in the same direction like our last example. So one's turned upside down than the other. So if we look at all the angles, we see that all the angles have a corresponding congruent angle, and we see that we have 2 segments on both triangles that are congruent. But for the line segment NL, there's no hash markings on it, but if you think about it, it's the same segment for one triangle as it is for the other. So of course that line segment is going to be congruent to itself. So even though the diagram didn't give me that information, I know that to be fact. Because if we would say line segment NL for one triangle, the line segment NL would also be congruent on the other triangle. It's the same line segment, even if they were pulled apart. So yes, our two triangles are congruent, and now we just need to write our congruent statement. So let's start with the first triangle. I'll start at point K, and I'll go KLN. So triangle KLN is congruent to, now remember K is congruent to M because they both have the same angle measure. So that's my starting point for my second triangle. And now I have to go in the same direction. So M, N, L. So triangle M, N, L. So triangle KLN is congruent to triangle M, N, L. And last but not least, we have these two triangles. So we can see that all the side lengths have corresponding congruent side lengths because we have one tick mark here, one here, two here, three there. But we don't know anything about these middle angles around point E. But remember from chapter 2, all of those angle congruencies that we talked about. This angle has to be congruent to this angle by vertical angles. So I can fill that information in because that's something from a previous unit. That's knowledge I know from a previous unit. So yes, our two triangles are congruent, and now we just need to write a congruent statement. So I'll start at point D on this triangle, and I'll go in this direction, D, G, E. So triangle D, G, E is congruent to, I have to start at triangle or point H for my next triangle, because remember they have the same hash marking telling us that they're the same degree measure, so those 2 points correspond to each other. And so next I have to go to F and then E. So D, or triangle H, F, E. So those are all 3 of my congruent statements. Hopefully that's starting to make a little more sense. For the rest of your assignment or video today, we're going to be doing 2 examples, and both of them you want to write down in your notes. So again, if you need to pause and write these examples down before I explain them to you, take a second to pause the video and write these images in your notes. So this is example 2, and we're trying to find the value of x given that the triangle FGH is congruent to the triangle RST. Even though on our 2 pictures of the 2 triangles, they don't have the hash marks listed or shown on their side lengths or on their angles telling us which specific side length is congruent to the other, but it all tells us in our congruent statement, which is this statement right there. Remember, that's why the order of those congruent statements is so important. So if we know that angle F is congruent to angle R because of the order in which they're written. And we don't know what the angle measure is for angle F quite yet, but we do know from one of the theorems that you've learned and practiced for a very long time that a triangle adds up to 180 degrees. So we could easily find angle F because 155 plus 65 is equal to 120, and 180 minus 120 is 60 degrees. So knowing that information, angle F is 60 degrees. And since we know that angle F is congruent to angle R, now we can set up an equation. We can set the equation up as 60 degrees is equal to 2x plus 30. I guess we don't really need the degree sign, so you can just ignore that. So now it's just a 2-step equation. We need to subtract 30 from both sides. 30's go away. 60 minus 30 is 30 equal to 2x. Divide by 2. X is 15. And that is our answer, and that's all we have to do because that's all the directions asked of us. So our last example here is to use the congruent statement to find the value of multiple variables. We have an x and a y, so we'll need to set up 2 equations, and yes, this will be a system of equations that we need to solve for both variables. So just like in our last example, we're going to identify which angles are corresponding to each other so that we can set up equations. And this image was nice enough to not only give us the congruent statement, but to give us the visual representation of these hash marks. So we know by both the image and the congruent statement that F is congruent to P. Angle F is congruent to angle P. And that's going to be our first equation. So negative 3x plus y is equal to 36. And again, that's because angle F is congruent to angle P. Now we need a second equation, and our x and y variable are attached to this angle R? Well, from our congruent statement, since we don't have any hash marks, R is congruent to H. So let's make those hash marks. Let's use 3. So R is congruent to H, or the angle R is congruent to angle H. Again, we don't have the degree measure on angle H, but we do know the angle measure of F and the angle measure of G, and we know that the total measure of a triangle is 180. So 36 plus 134 is 170, and 180 degrees minus 170 leaves us with 10 degrees. So that's our second equation. 2x plus 5y is equal to 10. So, like I said, this is a system of equations, and the first equation has y with no coefficient in front of it, so you could easily add 3x to the other side and use substitution if you want, and that's totally up to you. If you want to do substitution, you can go right ahead and do that, but I'm going to be doing elimination. And I want to eliminate the y variable. I want to get rid of these y variables, and if I were to add the two equations as they are right now, the y's wouldn't eliminate. So I need to manipulate one of the equations in order to be able to eliminate them eventually once I add the two equations together. So I'm going to subtract the top equation by a negative 5. So negative 5 times 3x gives negative 3x gives me a positive 15x, and negative 5 times y gives me a negative 5y, and negative 5 times 36 gives me a negative 180. And now all I have to do is add the two equations together. So 12x plus 15x gives me 17x. The y's cancel because 5y minus 5y gives me 0. So then we have 10 minus 180. That's a negative 170. Divide both sides by 17. Would you look at that? X is a negative 10. Are we done? No, we still have to solve for y. So I'm going to plug negative 10 back in to x in this first equation. So negative 3, I'll rewrite it here for you, plus y is equal to 36. So I'm plugging this value in for x here. So I have negative 3 times negative 10 plus y is equal to 36. Negative 3 times negative 10 is 30. It's a positive 30. If we subtract 30 from both sides, we will get y is equal to 6. And that is all I have for you, so I will see you on Monday.